Alrighty, folks, we are at the end of the chapter. It is 1-7. These notes look a little bit different because they came from the book, but we're still going to go through them and learn the last little bits of chapter 1 for our test on Friday. Okay, so today we're talking about graphing a little bit and how that ties into the equation and the functions that we've been working on the last day. It says you can use a graph to represent a function. So what we've been doing is listing the numbers as tables or ordered pairs. Now we're going to look at graphs. In a given table, each corresponding pair of inputs, remember that's your domain or X, and output, that's your range or Y, forms an what we call ordered pair. And you've probably seen this somewhere. That's going to be an X followed by a Y. That's an ordered pair. I can remember which order they go in because it's alphabetical. An ordered pair of numbers can be plotted as a point. So I'm going to put a point on the graph that represents that ordered pair. The X coordinate is whatever the input is, and then the Y is your output from the function. So this is just taking that new function language and going back to something we already know how to do, which is plotting the X and then the Y. The horizontal axis of the graph is labeled with the X. You guys know that when you have graph that the horizontal one is X and the vertical one is Y. And so then now the horizontal axis is labeled with the input, what we've been calling our domain values. And then the vertical axis, the up and down, is our Y. So that's going to be labeled with the output or the range. Okay, my pencil's kind of fat. Let's see if we can skinny it down. Nope, apparently that's it. All right, so let's do that. Let's go ahead and graph a function. So you guys have done this before. They're telling you the domain. So that is the X's. So my X's are 1, 2, 3, 4, and 5. It's asking me to make an input-output table. We would have called it an XY table in the past. It's no different mathematically. So what I need to do is use this rule to fill the table just like I did in the last couple days for homework. So for each X, I'm going to add 1. So if I add 1 to 1, I'll get 2. Add 1 to 2, I'll get 3. Add 1 to 3, I get 4. Adding 1 to 4, I get 5, and adding 1 to 5, I get 6. So now I'm going to plot plot a point for each ordered pair, X, Y. So you know how to do that. You just maybe are used to seeing them as 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. It's no different than what we've done in the past. It's just that these are going to be my X's and these are my Y's. So 1, 2, keep in mind, means I go 1 to the right, up 2. So that's my first dot. 2, and then up 1, 2, 3, because the first one's your X, so it's telling you how far to the right to go. In this one, I'll go 3 to the right and up 1, 2, 3, 4. Here I'll go 4 to the right and up 1, 2, 3, 4, 5. So the X is down here and the Y is over here, giving me those coordinates. And here I had an input, so the input is down at the bottom because that's my X's. My output is my Y's. So here I'm going to go to 5 on the input and up to 6 on the outcomes. And then I just leave it as dots for now. That's what we're doing, is plotting those specific points. All right, then let's take a look at another example. Now this is a little bit trickier because here, this is asking me to write the function for the rule. So here I have to actually kind of go backwards and think, okay, I'm supposed to identify the domain, which is the X's, the range, which is the Y's, and I'm supposed to write a rule. That can be kind of tricky. I really have to think hard about how they're matching. So I'm going to do this part first. So my first point, I would have called that 2, 0 before. This one, I go to the right 4 and then up 1. My third point, I went over 6 on the X and then up 2 on the Y. This point goes up from 8 as an input and then comes out as 3 on the Y. And my last point is going up from 10 and going over to 4. So when I go to lay it out this way, keep in mind, these are my X values. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That's going to be the x values for my table. That is also going to be my domain. Then my y's are going to go in this second row. So that's 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. And then we talked about that the last day or two, that's range. So when you put in a 2, you get out a 0. Put in a 4, get out a 1, and so on. So now what we have to do is we have to try to find the relationship. Like, how did I do that? We talked about the input-output. If I'm putting in a 2, how am I getting out a 0? What is the rule? Now, you might think just take away 2, but then that doesn't work for the second numbers where I put in a 4 and get out a 1. That's not taking away 2. So sometimes you have to look and kind of think about what's going on. So in this case, and this can be tricky, it's sort of a trial and error thing, but in this case, for each x, or let me say for each output, so like to get a y value, it's going to be 1 less than half of the input. Now that's tricky to come up with, but we're going to practice that. So for example, here, half of 6 would be 3. This 2 is 1 less than that. Half of 8 would be 4. 3 is 1 less than that. And so if I'm going to try to write a rule for that, I have to turn these words into an equation like we did earlier in chapter 1. So the y, that's my output, that's my equation, 1 less than half of the input, which is an x. So I would write 1 less than half of x like that. And that goes back to earlier in the chapter. This is 1 less than half of x. So that is my rule. This is without a doubt the hardest thing in the chapter is to find that rule. Some of you will be really good at it because it's like a puzzle, and some of you will struggle to find that relationship. The more we practice, the easier it gets. So in this case, the rule for the function is y equals 1/2 x minus 1. That's the rule. The domain is our x's. So looking back up here, that is going to be 2, 4, 6, 8, and 10. And then the range, which is my y's, looking back at my table, 0, 1, sorry, I skipped 1. 0, 1, 2, 3, and 4. So that's the range up here. Okay, so we're going to kind of go for the whole thing. We're going to start from the beginning, kind of make our way through. We're going to graph this function. So they told us the rule this time. And then we are going to use this as our domain. So I'm thinking that that's my x's. So I'm going to put an x here, and I'm going to use 0, 3, 6, 9, and 12. When I do a table, I need to then find the bottom of the output or the y's, and I find those by plugging in the x's. Some of you might be more comfortable looking at it like this, but it's no different. My x's are 0, 3, 6, 9, and 12. Here to get the y's, I have to plug them into this equation. So if I put in a 0, I would have 1/3 of 0 plus 1. Well, 1/3 of 0 is 0, plus 1 is 1. Here I'd have 1/3 of 3 plus 1, so that will turn out to be a 2. If you need your calculator, go for it. 1/3 of 6 plus 1 is a 3. 1/3 of 9 plus 1 is a 4. And 1/3 of 12 plus 1 is a 5. So to plot my points now, I'm going to use these as 0, 1, 3, 2, 6, 3, 9, 4, 12, 5. And I'm not doing anything differently. I'm just writing them out in a different way that might look a little more familiar. So if I go here, 0 and then up 1, here I'm supposed to go over 3. This is tricky because it's counting by 2's. So 3 is going to be in the middle here, and then I go up 2 from there for this point. Here, I go over to 6 on the input, up 1, 2, 3. Here, I'm supposed to go to 9, which would be here in between the 8 and the 10. So now I'm going to go up 1, 2, 3, 4. So I'm kind of in the middle. Here for 12, I'm right there, and I'm going up 1, 2, 3, 4, 5. So that is the whole thing from beginning to end. And if I was asked for my range, which they didn't ask for, I would simply list my y's of 1, 2, 3, 4, and 5 from this table. All right. So the hardest thing, like I said, is writing the rule. So we're going to practice this. And then that way we can maybe get some experience, but without a doubt, this is the trickiest part. So on the test, I'll either make these really easy or maybe I'll make these extra credit, but where you have to like figure out the rule on your own, I'm going to try to take it easy on you a little bit. Okay, so we're looking for the rule. And so we're going to start, in my opinion, by writing out a table for our domain and range. And I'm going to write it this way for space. This point is at 1, 0. This point is over 2, up 3. See how it's in between the 2 and the 4? So 2, 3. This point is over 3 on the X, but up 6. Then the next point is 4 on the inputs, comes out in the middle of 8 and 10, so that's a 9. And so these are my domain values, these are my range values. So it says identify the domain and range. So I did that. And then my rule on this is really tricky, and you have to kind of look through and look for patterns that work. And in this problem, I ultimately land on this, where I would be taking 3 times these numbers. So 3 times 1 would give me 3. Then I have to take away 3 to get this 0. Testing it out on this one, 3 times 2 minus 3 would be 3. So that checks. Testing it out on the third one, 3 times 3 is 9, minus 6 is, minus 3, sorry. Minus 3 is going to be 6, and so on. So it's pretty tricky, and that's nothing but guess and check. If there was an easy way to come up with a rule, I would definitely tell you. But you just have to kind of muscle through those. Okay, let's try this one as well. So the first thing I'm going to do is identify my domain and range, but I'm going to do it in a way that's familiar. This point looks like I go over 2 and then up 6 on the Y. Here my input or X is a 4. My outcome's coming out between 6 and 8, so that must be a 7. And then here this one's going in at 6, coming out at 8. And the last dot's going input 8, coming out halfway between 8 and 10, which is a 9. So my domain is the 2, 4, 6, 8. My range is the 6, 7, 8, 9. And again, here I have to look and try and practice trying to match these up. What did I do to 2 to make it turn into 6? And then that rule has to hold for all of them. And what I'm coming up with is I have to take half of the X, but then add 5. And that is, like I said, super tricky. So for example, here I would double check it and say, does half of 2 plus 5 equal the 6 that I got? Half of 2 is 1, plus 5, check. Does half of this 4 plus 5 equal 7? That would be half of 4 is 2, plus 5 is indeed 7, check. So this is the right rule. It's just tricky to come up with because there's no easy way to do it except for guessing and checking. And again, those of you that are good puzzle, kind of math puzzle people might be really awesome at that. And those of you who aren't might struggle. So I'll take a look at those on the test and make sure those are not going to count against you and that you could find the rules more easily. All right, so that's the end of the chapter. So tomorrow you're going to do a little more practice with 1-6. Then on Thursday, you're going to be reviewing the whole chapter so that on Friday you can be super awesome and prepared for your test. So you're going to look at page 46 for this. We're going to do 10 through 13, 15, 16, 19, 22, 24, 28, and 30. So take your time to do those. That's not super long, but those have a couple of tricky bits to it. So do those and then keep in mind that tomorrow you can watch the homework help videos. If you have trouble on any of these, you can go back and watch your homework help videos. So those will be available in the daily folder, but these, give them your best shot and then turn in your 1.7 assignment check by 8 o'clock.